Hello Year 12 and welcome to MM6 Spherical Geometry. What we're going to do in this topic is we are going to describe a location on the Earth's surface using a coordinate system called latitude and longitude. We are going to calculate the distance between 2 points on a great circle, right, which we'll learn a bit more about, and we're going to have a look at some differences with time zones. Okay. So, first of all, describing our location on the Earth's surface using latitude and longitude. Okay, this is a coordinate system, a bit like the XY system we use on a plane, except this is not a plane surface, it's a curved surface. Right? So, our coordinates work slightly differently. First of all, we describe our latitude. Now, when we're talking on a plane, XY coordinates, we give the X, which goes across first. In terms of latitude and longitude, we give the up or down bit first. That's just the way it's done. Now, we measure that latitude, the up or down part, as a distance above or below the equator. Now, the equator is this line that goes around the middle of the Earth that is the same distance between both the poles. And in fact, it is pretty neatly 10,000 kilometres away from each of the poles. Right, so it goes around the middle of the Earth. That's as big a circle as it could be. It has a centre. The centre of that circle is the same as the centre of the Earth, right, the equator, and it separates north from south. Okay, so we measure how far above or below that equatorial plane we are. We measure that in degrees, where the equator is 0 degrees, and the poles are 90 degrees away from there. Okay, so if you think about this, I'm just going to sketch an extra circle in here. Imagine that I've cut the Earth in half. There's the North Pole, there's the South Pole. Right, the equator runs across there. Now here's the centre of the Earth. So if I draw a line in there from the centre of the Earth over to the equator, and then I have some unknown point here on the surface. If I draw a line, right, imagine that I've cut through the centre of the Earth here. I've drawn that line there and I measured the angle between the equatorial plane and my location on the Earth's surface. That is our latitude, right? And you can see here that if my angle was 0 degrees, that's going to be 0 degrees, then I'm on the equator. Right? As that goes up there, it goes to a maximum of 90 degrees north, or it could come all the way down to 90 degrees south, right? That angle of there. There's no point having some line over here and measuring all the way around there, right? Because, right, it would be more sensible to measure the other direction there. Okay, so our latitude has a maximum of 90 degrees, north or south of the equator. Rightio? Wonderful. Now, these lines, so you can imagine that anywhere along this horizontal, if you will, line here would have the same latitude. Righto? So we talk about parallels of latitude, right? Because they all sort of run parallel to each other. They're all parallel to the equator. Now we need to measure our longitude, which tells us how far east or west of something we are. Now, this is a bit artificial, this something. The poles, right? The poles have a nice physical property, right? That's sort of where the Earth spins around. But in terms of east or west, the world's pretty smooth and it keeps on spinning. We have to make some point and say this is the boundary between east and west. Some time ago, that boundary was decided to run through the Royal Observatory in Greenwich, outside of London. So we have this vertical line, if you will, this line that goes from the North to the South Pole and passes through London, and that's sort of our zero in terms of east and west. Anything east of that line has an easterly longitude, anything west of that line has a westerly longitude. Now, we could go from that line all the way around to the back, would be 180 degrees. That would get you somewhere over near Samoa, perhaps. Right, you could go 180 degrees around one way or 180 degrees around the other way, either east or west. So our longitude could be anything from 0 degrees all the way around to 180 degrees, either east or west. we are at about 150 degrees east. Now, these lines that define our longitude, right, they all join the North and the South Pole. So we have this Greenwich meridian here, or the prime meridian. That's our sort of 0 point, in the same way that the equator is our 0 point for latitude, for north and south. And all of our other meridians of longitude all sort of loop around like this. They all join the North and the South Pole. Looks like an onion here. Okay, they all join the North and the South Pole. They are called meridians of longitude. Our meridians of longitude tell us how far east or west we are. Our parallels of latitude tell us how far north or south we are. Okay. Now, let's have a look at this little exercise here. Now, you won't be asked to do something exactly like this in an exam, right? Now, this diagram is going to get a little bit complicated, right? But you do sometimes have to work out the difference between latitude and longitude. So what I'm going to do here is I'm going to try to represent the whole Earth's surface on this circle. So first of all, I'm going to draw in, that's going to be my prime meridian, right? It's north and south. And so London would be, I don't know, up here somewhere. And I'm going to draw my equator across here. So that's going to be 0 degrees north or south. Anywhere along that line is 0 degrees north, 0 degrees south. Anywhere along this line here, sorry, that's my North Pole and my South Pole, right? That's going to be 0 degrees along that line, east or west, right? Anything on that line would be either 0 degrees east or west. Now what I want to do is I'm going to spread all the way around to 180 degrees here. So I'm going to say, you know, Samoa is over here somewhere, New Zealand over here somewhere, Australia over here somewhere. Now, that's going to be 180 there. Right, so I'm going to call this line here 180 degrees east, and this one 180 degrees west. Halfway in between. I'm just going to put some dotted lines in here. Now, this is not going to look exactly like some picture of the Earth, because we're taking the whole spherical globe and sort of squishing it onto one circle, right? So this line here I'm going to call 90 degrees east, right? And I'm just going to press pause here and fill in some things. Okay, hang on. Okay, I'm back, right? I've put some extra lines on here, sort of like grid lines, so we can see what's going on a little bit. Now, this is going to be this vertical line here, my prime meridian, my equator, right? And I've marked off 30-degree intervals of longitude, right, spreading out there. So it goes from 0 to 30 east, 60 east, 90 east, and so on. And 30-degree intervals going north and south as well. So this is going to be 30 degrees south, 60 degrees south, 30 degrees north, and 60 degrees north. Okay, not much is happening, to be honest, up above 60 north and 60 south. So we're going to try to label these points here. A, 30 north, 30 east. So first of all, I need to go north of the equator, 30. And then I want to go 30 east, which is this way. So I'm going to have a point here called A. B, 30 north, so it's on that same parallel, and 120 east. Right, so this is my 90. This is 120 here. So there's B. Got A and I've got B labelled there. C is at 15 south, okay, so somewhere around here, and 135 east. Right, so again east, here's my 90, 120, 135. So I reckon I'm about here for C. D, 45 north, 75 west. So 45 north, 30, 60, 75. Right, I reckon that's D around there. And notice that's west of my prime meridian. 50 north, and I've got 0 degrees. Now I could call that either east or west. Right, it means it's on the prime meridian. 50 degrees north. Right, so D was at 45. This is slightly more up here, 50 degrees north, 0 degrees east or west. That's E. F, 37 south, so down here somewhere, 175 east. Right, and that's nearly all the way around here. So I reckon that's about here. Oops, somewhere around here. That's F, 35 north, 140 east. Okay, 30. That's my 30 north, so 35 just above that, 140 east. So this is 90, 120. That's going to be 150, so it's going to be about here. Now it was 35, so it's just about there. Fairly close to B. It's G and H, 40 north, so just north of that, 115 east. There's my 120, so it's just north of here, so it's in around there. Okay, and there's H. So we've got a diagram there, sort of showing where those points are. We can see that B, G, and H are fairly close together. D and E, I suppose, are sort of, kind of close together in a way. Now, I want to work out the difference in longitude and latitude between these points. So from A to B, right, we can have a look. Here's A and here's B. We can't measure it with a ruler or anything like that. Now, from A to B, I have to zoom out a little bit. Now, our difference in longitude is 30 east and 120 east. Now, because they are the same, they're both east, we subtract. Same subtract. 120 minus 30 is 90 degrees difference in longitude. Right? And then their latitude, well, they're on the same parallel, so 0 degrees difference there. Between C and D, now this is quite a tricky one between C and D. So, our longitude first, 135 east and 70 degrees west, 75 west. They are different, so we add them. Now, if I add 135 and 75, I get 210. That's not a very good answer. We don't want anything more than 180 degrees, right? If it's 210 degrees one way, right? If you think about having a circle here, right? If I have an angle of 210 degrees, it would be like that, right? 210 degrees, more than 180. It's a reflex angle. Right, now, if I want to find the difference, generally, if I want to know how far it is from A to B, I would be silly to go this way, generally. I'm interested in this one here. So how do I work out this angle here? I take the 210 away from 360 and I get 150 degrees. Okay, 150 degrees in longitude there. When we're talking distance, that's the way to go. When we're talking time, we might deal with things differently. But for distance, to get from A to B, I'd be much better off going this way than that way. Now, the difference in latitude from A to B is, let's have a look. Now, it's 15 south, 45 north. They're different, so we add them. I get 60 degrees. That's quite a complicated one. The others, not so bad. From E to F, we see it's 175 degrees. Okay, so just shy of that 180, right? It's still a long way apart. And 87 degrees difference in latitude, right? E and F, they're a long way away. G and H, you see I've got 25 degrees difference there and 5 degrees difference here. Rightio. I think I'm going to have to pull up my video there because that's been quite a long time. Anyway, review that. Let us know if you've got any questions.